Hi everyone, welcome to Spidermatch. I'm Jimbo Freedman. I'm a data engineer at Huck Industries in London, and we're here to show you what we've been working on in 2023 and how what we've built can help not only our clients, but also the whole open mapping community. At Huck, we provide location and mobility intelligence to government, retail, real estate, and financial sectors. We can show you, for any given location, defined by a set of polygons that you give us, first of all, the footfall, which is how many visitors a location seen over a given period, the visit density, which is which locations they visited in the polygon you've given us, and the catchment area, the dwell time, which is how long that they spend in the area, and then also the catchment, which is where your visitors are coming from. Our clients use this to monitor their existing properties, see the effects of special events in the area, and even make long-term strategic decisions, such as choosing locations of new stores. Of course, in order to know where these visitors are going, we need to know what's actually there. So it should come as no surprise to you that we're mostly interested in scoping point of interest data from all of your worldwide favorite brands. This is where All the Places comes in. All the Places is a wonderful open source project that's been around since 2016. And in those 7 years, they've steadily built up a repository that now counts around 1,800 spiders, all of them built by volunteers, returning around 4.5 million items. Although actually, about 1.5 million of them are all ATMs from a single spider that crawls the Visa website. The upstream version runs on their own infrastructure, but we've been using Scrapey Cloud, and we've just started testing out the Zite API for our proxy needs. We run these weekly because it's going to be important for us to keep track of branch openings and branch closures. And then we export the results to GCS so that we can have fun with them in BigQuery. As I'm sure all of yours do, the spiders themselves vary quite significantly in complexity. We have a lot of the same challenges as you. Sometimes there'll be a perfect XML sitemap that tells us exactly where we need to go. And sometimes it's so good, this is the Hilton one, that single XML file is 1.4 gigabytes. It takes us quite a while to get through the whole thing. Sometimes there's a JSON API that just gives us everything we need straight off in a lovely machine-readable format, or occasionally lies to us about the record count to keep us on our toes. But unfortunately, sometimes we have to go through the store locator just like a human would, and it only searches a 10-mile radius, returns a maximum of 25 results so that we have to use it recursively over a smaller area, and we have to search the entirety of the US on that 10-mile grid. That turns out to be about 34,000 requests, if you're curious. Fortunately, there is a shortcut. One of the things that our planet's largest nations have in common is vast swathes of empty space, and we're already sitting on a treasure trove of data with OpenStreet. We can make some very reasonable guesses as to where the coffee shops in the US might be. They tend not to be in places that, for example, don't even have any buildings. So what if we took our 34,000 10-mile searches and checked every single one of them for the presence of buildings on OpenStreetMap in advance? The good news is that we can discard 32% of them straight off the bat, bringing us down to 23,000 requests. Of course, when you're looking at this map, you'll think that it couldn't possibly be 30% gone from it. And it turns out because all the empty space is in Alaska. When we apply that strategy to Australia, we can save 47% of our requests, and to Canada, a whopping 84%, dropping from 82,000 searches to only 13,000. As you can imagine, this is very good news when we look at our proxy costs, and we'll just have to take the risk on missing out on a coffee shop up in the Arctic Circle. So now we're sitting on our wonderful stash of 4.5 million points of interest. It's time to do something interesting with them. First of all, we're going to discard all the ATMs because we just aren't bothered about them. And then we'd like to, but we'd still like to keep the scraping history in case we change our mind later. Unfortunately, we have a small problem. There are a lot of errors in our scrape data. Looking around the map, we can see that some store finders have duplicates. This is South Kensington Station in London, and Pret a Manger are claiming that they have two branches not even right next to each other, but in the same building. That would be very easy for us to deduplicate. But what range should we choose for our deduplication? Just 1 kilometer to the northeast, towards Knightsbridge, there are two branches legitimately 100 meters apart, and they have the same street and postcode. When we're dealing with points of interest that range in size from a postbox to a national park, we have to be very careful about choosing a strategy that's flexible enough to match all of our different categories, especially as the coordinates can sometimes be off by hundreds of meters. Remember that these pins were put on a map by someone who has probably never physically visited the branch that they're mapping. Fortunately, the metadata is often correct, and that's going to come in very handy later. But our particular challenge comes around train stations, shopping centers, and airports. The coordinates that are off can confuse us when we're in a building. When you type a postcode in for a shopping center into a website, you'll often just get the service entrance. So we sometimes see that every point of interest in one large building is stacked onto the same point. These are all the threats around St Pancras International and King's Cross Station, and I can't even tell you if those are all real. I'm actually planning to walk up there next week and just count them myself so we know what we're dealing with. And when I said the coordinates could be off by hundreds of meters, sometimes it's tens of kilometers. This service station in the Midlands is supposed to contain 2 hotels, but they've both been geolocated to a village to the northwest. And then for Marks & Spencer, who we'll be revisiting later, they're claiming to be opening Marks & Spencer branches on drilling platforms in the North Sea. But then if you actually look at the address, they're both in Glasgow. I have a feeling that whoever put those on the map was particularly bored at work that day. And this isn't going to do when we're trying to count footfall into shops. So we're going to have to validate all of this before we can show it to our users on a map. OpenStreetMap, in case you haven't heard of it, is the Wikipedia of mapping. It's been painstakingly created by millions of contributors over the past 20 years, and it's available in its entirety under the Open Database license. With the benefit of local knowledge and satellite photography, it can be more accurate by anything created than a machine, and will even, in many cases, give us the footprint polygon of the building that we're interested in. This is St Pancras and King's Cross again, and you can see the level of detail in where all of the points of interest are. In addition, the editor makes use of a project called the Name Suggestion Index, a sort of autocomplete for metadata that adds information about a brand and a store type from the moment the contributor has typed the first word. So as soon as you type Pret in, you're automatically given the brand identifier, the category, the cuisine, and even sometimes things like the presence of a drive-through or vegan food. Sadly, the Name Suggestion Index isn't always made use of, so we have to stay aware that for OpenStreetMap, we can't rely on it in the same way as we would the information from the brands. This DIY store in Switzerland is only identified by its name. Whoever added it didn't use the Name Suggestion Index, so we have no category and no brand, and we're going to have to find it the hard way. So now we have our 2 data sources available, All the Places, which is generally up to date, has extremely accurate metadata, but variously sketchy location information, and OpenStreetMap, which can often lag behind and is frequently missing metadata, but when a feature is present, its location is perfect and even includes the shape of the building. So we need to find a way to match them up. All the Places is, luckily for us, created and maintained by members of the OSM community. So we start with a whole lot of metadata that's in the same format. For this, we're now going to focus on the shop and amenity types. So is it a coffee shop, is it a supermarket, or a petrol station, or a brat bank? And the extremely useful brand Wikidata ID that effectively records the name of the owner from the Name Suggestion Index. Where OpenStreetMap features are fully tagged, we can simply look for points of interest of the same brand in each dataset that are under a certain distance threshold and have the same shop type. Here, you can see a map of the Costa Coffee branches in London. The All the Places features are in green, and the OpenStreetMap ones are in blue. And where we've matched them, we can draw a line between them. And you can see how the distances are off, but not by very much. When they're not matched, the All the Places ones are orange, and the OpenStreetMap ones are pink. And we're going to keep that color scheme throughout the rest of the presentation. Those 50 meters are critical when we're trying to link a GPS point to a particular store, so we're really interested in knowing that these branches aren't in the middle of the road, but they are in this specific building. Results from our first attempt at matching vary wildly across Europe. All the Places is much more fleshed out in the UK than it is elsewhere. This is largely thanks to one particularly productive contributor. But it looks like the OpenStreetMap contributors in Germany and Austria are much better at mapping the stores with all of the correct metadata. Unfortunately for the Mediterranean, which we're now branching into, we're quite a bit behind, and we're going to have to come up with a new strategy for that. This is actually explained by a variation in a few key brands. Some are heavily standardized. There are no different kinds of Lidl stores or McDonald's. compared to, say, Tesco, which has Express and Extra and Central. So the metadata is a lot easier for us to match exactly. But at the bottom, we can see a pub chain that few will know by name. Marston's. Nobody knows their local pub by its brand owner. We all know them by their names, the White Horse, the King's Head, and so on. And that shows when they're mapped. When you type the King's Head into the OSM editor, it's not going to suggest anything to help you because it simply doesn't know. Let's look at a particular example, Marks & Spencer. Is it a supermarket or a department store or a clothes shop? Sometimes it's even just a convenience store for their Simply Food branches. One of the great long-running debates on OpenStreetMap is actually about the boundary between a convenience store and a supermarket, and there's been some quite intense arguments about the presence of shopping trolleys. Some of Marks & Spencer's food-only branches are embedded into BP petrol stations, so they could be tagged as BPs. What if the OpenStreetMap feature is mistagged? Not only do we have a metadata issue, but the naming is inconsistent across OpenStreetMap. We've tried some fuzzy matching in queries, but we wanted to make sure that we grab the feature right every time. And of course, like everyone else here, we decided to use an LLM. We originally tried Vertex AI's text bison model out of sheer curiosity. What could we achieve in half an hour? But the results have been good enough that we fleshed it out more and tried it across the whole continent. We're going to start with the rest of our OSM features that have the correct brand Wikidata identifier, so a list of all the Marks & Spencers we haven't matched yet. This can help us find the ones where the brand is a Marks & Spencer's food hall, or there's a cafe attached with a slightly different name. So for each remaining OpenStreetMap feature, we'll take a look at the all the places options within 300 meters and let it make a best guess on which one is most suitable. That will neatly sidestep our supermarket versus convenience store issue. Let's see how this performs for us. So this is what we had before for Marks & Spencer in London. And afterwards, we now have a nice new sea of green. Looking at the results, we've managed to match up far more of them. It may seem like the answer is always obvious here when they're not that close together with a few rare counterexamples. But when you're looking at things like 7-Eleven or Starbucks in the financial district of New York, there could be a branch on every single block. So if we're out by even 50 meters, we could have a problem. After our stage 2 using Vertex AI, we've taken a good 5 to 10% chunk out of our remaining all the places features. And brand-wise, you can see that some of our brands with less consistent tagging have benefited enormously. As well as our success with Marks & Spencer's, we've seen good progress with Shell and BP, both of which suffer from their brands often being mistagged as BP Connect. Now that we've solved Marks & Spencer, let's see if we can see what the problem is with Marston's. Our most useful metadata tag, brand Wikidata, isn't going to help us anymore because it's not there. Nobody looks at that pub sign right here and decides that Marston's is what they're going to remember. We'll have to rely on the name being correct, which sometimes it is. So let's see if we can fix that. We're going to have to throw more options at our query this time. So we're going to use every OpenStreetMap feature next to a particular all the places feature. Not quite every. We're going to strip out the roads and the trees, but we still have quite a lot of options to deal with. We're going to look for a match on the name or for a name that matches for the brand. So if you put BP in for the name, but BP Connect as the brand, it will still get you for BP, along with matching on the store or shop or amenity type. Let's see what happens. That's much better. We found a good chunk of the Marston's pubs in the UK, but we still have quite some way to go. After our third round of matching, we've snuck a little bit further towards our goal, but no particular surprises by country. But for the brands, this has been surprisingly effective, notably for Marston's, but also for Shell again, and for Billa, an Austrian supermarket that has somehow from their website snuck a lot of the addresses into their store names. Our pattern is to take each approach here as something that will help a subset of brands without introducing too much of a risk of a mismatch into the rest of the data set. We don't want to get dragged too far into writing custom strategies when we have nearly 2,000 different spiders to worry about, so we're trying to find something that will help everyone. Can we find the rest of these pubs? Now that we've matched 20% of them up, we at least have an idea of what the problem is. The naming is inconsistent. In this instance, Marston stripped the word "the" from the start of all their properties. And that could be a simple problem for us to fix with a little bit of more fuzzy string matching, or maybe using the Levenstein distance. But when you're looking at this issue in so many different ways across so many different languages, it's going to be hard to find something that isn't going to get us confused later. So we're going to go back to the LLM, but we're going to take some training examples with us. This time around, we're going to give the LLM that same set of potential features that we used in stage 3. Everything man-made and above ground for a few hundred meters in every direction. We also have some examples that we can use in previous rounds. And so we're going to feed it those and get an idea of what a good match is. This is a much more dangerous game than it has been before, because our matching candidates aren't just limited to features from the correct brand. So we can see how it performs. This is what we had before, just over 20%, but with a very high degree of confidence. And now we're at 95%. This looks fantastic. But sadly, we've come across this classic issue with LLMs. Their innate desire to make their masters happy, it makes them prone to bending the truth a bit just to answer the question. So some of these are doctor surgeries, some of them are banks, some of them are petrol stations, some of them are parks. But if it can't find anything that's relevant, even with the examples, it will just make something up for us. Most of these aren't even actually matches. They're just buildings with the same postcode or a similar word in the name. For example, the name of the village. And this isn't going to work for us. We know we're never going to hit 100%. Neither of our sources are good enough for that, and we can't tool the word checking everything manually. Although, interestingly, one of our competitors in this space does exactly that specifically in London. They have people walking up and down the high street, noting down what shops have opened and what have closed. So it's safer for us not to use this overreach and go back to fixing the holes in the map so that we can match better the next time around. Where can we take this in the future? Now that we've seen what we could achieve just with prompting, we're building a tool that uses scored similarity searches to give us confidence levels on our later stage matches. We can get a baseline for each brand with the ones we've achieved with queries alone and our stage 2 LLM, which is a lot safer. Our initial tests on this have been promising, so we're hoping to see much better scores in the near future. Most importantly, we can feed some of this data back to OpenStreetMap. They have 2 community apps, Map Roulette and Street Complete, which give users questions about the features that they're walking past. Is this shop still open? Do these stairs have a wheelchair ramp? And so on. Not only can we improve the metadata for the existing features, but we can also identify both new branches that are completely missing and recently closed branches that need to be removed on the map. So using Street Complete, we could have somebody actually walk to the store or where we think the store is, and then find out exactly where it is and add it to OpenStreetMap. Of course, we're also going to be writing many, many more spiders, probably taking advantage of the fantastic techniques we've learned about yesterday and this morning, and using our combined history of all the places in OpenStreetMap to identify the open and close dates of our stores so that we can show our clients how different brands arriving in the area can affect visitor behaviors. That's all I have for you today. Thank you for listening, and I hope you've enjoyed this very specific map tour of the United Kingdom.
All right, so we have a few minutes for questions. I have one question. Why only OpenStreetMap? Why not any of the other versions that are out there, alternatives?
So there's a new data set called, I've actually forgotten the name of it, maybe you already know. But it was released by a combination of Facebook and Microsoft a couple of months ago, and we found it to be less accurate than what we already have. So much of their data comes from things like Facebook Places and so on, and we just don't have the trust that, again, the coordinates are accurate. But the key thing about OpenStreetMap, aside from its license, is that you can be absolutely sure that the buildings are where they say they are. They may not be tagged correctly, but they've all been traced from satellite imagery.
Juan has a similar question about Google Maps. Is it a threat to OSM?
Honestly, even though it might be considered as a threat, it's simply not. Google are very, very protective of their own data. The license terms of the Google Places API forbid you from storing or caching any of your results. So OpenStreetMap's utility to businesses will keep people driving to use it. So many of the big contributors are working for organizations like mine or for TomTom, who do a lot of the support work relating to it.
Okay, so we have one about false positives. How do you validate them, especially at stage 2?
One of the reasons we chose stage 2 as it is because it's particularly safe. As long as we've got that brand identifier there, we know we're not going to tag the wrong store, and the distance prevents us from getting the wrong thing. In terms of the validation, we've had to accept that we're never going to score flat out 100%, and we haven't seen any big errors yet, but as our clients start to use this platform, we're expecting to see a couple. And then with the training that we're introducing, we can start using our confidence scores to be better at the validation.
You alluded in the talk about a lot of the data is UK, and you're obviously training a lot of stuff in the UK. And as you start to move to other countries, what are you seeing as being the kind of the differences in either how people are tagging them, or naming conventions, or cultural scenarios, or any of that?
Oh, the conversations around that with OpenStreetMap can get completely wild. There are so many different conventions around the world, but the name suggestion index, the thing that we rely on, that's particularly consistent, largely because it's a GitHub repository with pull requests. So yes, OpenStreetMap has its risks, which is that anyone can add to it. There's been a few issues lately with people in some specific areas, maybe mentioned in the last talk, having a bit too much fun, and some big reverts have been happening. But we use data that's delayed by a month, and we found that the only big problem we have is countries where the mapping is just behind, there aren't enough contributors. In Western Europe and the US and Canada, we're generally okay. We've tried this in some of the Gulf states and in the Philippines, and a lot of the data on the map isn't there yet, especially in the Gulf states where, I mean, buildings and towns are being built faster than you can map them. It's hard to keep up.
Interesting. So here's another question. What kind of techniques are used to get foot traffic and time spent?
So we use completely anonymized location data. It's gathered from mobile phones with consent. And then we aggregate all of that and build GPS traces that we can then track around the world.
And then I think you kind of alluded to this one again, dealing with franchises with multiple locations inside a mall and so on.
This is a perfect case of where we're completely dependent on OpenStreetMap. If we didn't have access to it, we would just see them in exactly the same place. That Pret train station example I gave you is perfect. And we could know that they're in the same building, but without the OpenStreetMappers to help us, we'd be completely blind.
And I think we have another one just come in here about the difficulties if you do have multiple sources of information for the data. Any thoughts on that?
We considered trying to include this Facebook data set, and I'm so sorry I can't remember the name of it. But really, yeah, when you have two places, two data sets, we know that one is good at one thing and another is good at a different thing. For a third, we'd have to start coming up with some kind of voting strategy. I'd be very interested to see how that works out.
Interesting. I asked the question earlier, and I'm going to ask you again. This one about, if you could make, one key problem that you guys have kind of go away in either the collecting of the data or processing it or something, what would that be?
I would absolutely love it if all these brands put the same effort into knowing where their branches were that we did. I can't believe that, I mean, for us as consumers, it's a problem as well. You can be looking for a shop that you want to go to, and you go to where it is on the map, and it turns out it's 400 meters away. Like, it's, in my mind, unbelievable, and I'm sure a lot of the engineers there would agree with me, but it's just the reality of the situation we're in.
Brilliant. Well, listen, that was a fascinating talk, Jimbo. Thank you very much.
Thank you so much.